This is the practice test for Chapter 11 on conics. All right, when we go to graph conics, the first thing I want you to determine is which type of conic it is so that you know what it should look like when you're done graphing it. Well, this equation, x minus 3 squared plus y plus 2 squared equals 16, is a circle. And the reason I know it's a circle is because it's in the form x minus h squared plus y minus k squared equals r squared. When you go and find hk, remember that the general formula has a minus sign in the parentheses, so the center of the circle is going to be at 3, negative 2. So the first thing I'm going to do is put a dot at 3, negative 2 on my graph. The radius is the square root of 16, which is 4. So to draw my circle, I'm going to go 4 units to the right. I'm going to go 4 units to the left, put a dot. I'm going to go 4 units up, and I'm going to go 4 units down. And the reason I'm doing that is because all radii of a circle are congruent. So if this is the question on the test, when I grade it, I'm looking for these dots on the outside of the circle. I'm grading you on, did you get the center right? And did you get those 4 dots on the outside of the circle? Part B is an ellipse. The reason that I know it's an ellipse is because it's equal to 1 and it has that plus sign between them. Hyperbola are the ones that have the minus sign between it. Since this is in the form, first thing I want you to notice the larger number is under y. That means that the major axis is going to be elongated vertically or along the y-axis. The center, remember, be careful, is at 3, negative 2. So I'm going to put a dot at 3, negative 2. And remember, this is actually your a squared. Well, what it's going to tell you is you're going to put a dot 4 units above center and a dot 4 units below center. This is your b squared, but it's telling you you're going to put a dot 3 units to the right of center and 3 units to the left. And there's my ellipse. This next conic is hyperbola, and I know that because of the minus sign. The center is still hk. H is always in the parentheses with x. K is always in the parentheses with y. So the center is at negative 1, 2. So here's my center. Remember that the variable that comes first is the one that tells you if the little hyperbola open up and down or left and right. Since y comes first, this is going to be the hyperbola that opens up and down. So I'm going to put a dot 2 units above center and a dot 2 units below center. But before I draw my picture, I'm going to make my little box in the middle so I have a fairly accurate picture. So I'm going to also put a dot 3 units to the right and 3 units to the left of center. And then here's my box. The diagonals of the box are my asymptotes. So now when I go and draw my hyperbola, I know that it looks like this. This last conic is a parabola, and because x is the variable that's squared, it's particularly the parabola that opens up or down. In this case, it's going to open up. This equation is currently in vertex form, the form we learned in Algebra 2. If you'd like to write it in the form we've been using, it would be x plus 4 squared is equal to y plus 1. All I did was I flip-flopped the 2 sides and then I added 1 to the other side. So 4p in this case would be 1. So if I wanted to know what p was, although in this problem I don't ask that, I just ask you to graph it. So this is a parabola that opens up and down, or up specifically. The vertex, which is at HK, is at -4, -1. So here's my vertex, here's my axis of symmetry. And then if you want to do a fairly accurate drawing, you can use the graphing calculator to help you. It doesn't work as well if you're trying to graph a parabola that opens left or right, but at least you can get a fairly good idea of what's happening, or you can make yourself a little table if this were a parabola that opened left or right. But at least you can find the vertex and you know where the axis of symmetry is. And if you can at least find a point or two on one side of the axis of symmetry, you'll know where points lie on the other side of the axis of symmetry. Just like we did in Algebra 2 when we were translating graphs, we can translate conics. And really that's what's happening when we add in a number for h and k. The original equation here, x squared minus y squared, oops, that should be x squared, it doesn't matter, x squared minus y squared equals 24. And I want to rewrite this equation, which is a hyperbola, and I want to write it so it's translated 4 units to the right and down 2 units. Well, when you move a graph left or right, you're changing the x value. So I'm going to make this x minus 4 squared. And then in order to move the graph 2 units down, this is going to become y plus 2 squared. Wait a second. If I'm moving the graph down, why did it become y plus 2? Because what happens when you plug a negative in? It's going to be y minus -2. And that's where the plus 2 comes from. And this would be the equation that's been translated 4 units to the right and down 2 units. Sometimes we're given the equation of a conic in general form rather than standard form. So I want to find the center and the radius of the circle defined by this equation, except it's not written in my x minus h squared plus y minus k squared equals r squared form. So I'm going to have to do that. In order to do that, we do a process called completing the square. We put the x's together, and we're going to create a perfect square trinomial. We put the y's together to create a perfect square trinomial. Notice that I move the constant to the other side of the equal sign. And the rules of creating perfect square trinomials is that whatever you add to one side of an equation, you also have to add to the other. To find the number that goes in the blank, you really just take the middle term, divide it by 2, and then square it. So the first one is 4. And if you take this term divided by 2 and square it, you get 25. The reason we create perfect square trinomials is because they're really easy to factor. This factors into x minus 2 squared, and the second one factors into y plus 5 squared, and then the other side simplifies into 16. Now that's an equation that I understand. Now I can tell you the center is at 2, -5, and the radius is 4. In problem 4, I want to determine, without doing any work, which type of conic is represented by each equation. I claim to you I don't have to do anything. So if you look at example A, I want you to notice that there's only one term that's squared. If only one of the two variables is squared, it's a parabola. This happens to be a parabola that opens up or down. Look at part B. Only focus on the square terms. I want you to notice that x squared and y squared have the same coefficient. If they're both positive and they both have the same coefficient, it's a circle. In problem C, when I look at my x or my square terms, I want you to notice that they're opposite signs. One of them is positive and one of them is negative. When that happens, it's hyperbola. And in D, my square terms have different coefficients. If the coefficients are different and they're both positive, it's an ellipse. In problem 5, we're going to put each conic in standard form, and then we're going to identify important characteristics about each conic. First of all, I want you to note that example A here is a parabola. As a matter of fact, I happen to notice that this is already a perfect square trinomial. So I'm going to write it as y plus 3 squared. On the right-hand side, I'm going to flip these. And instead of 12 minus 12x, I'm going to write it as negative 12x plus 12. I want to write this so it's in this format. In order to do that, I'm going to factor negative 12 out of the right-hand side. Now, this is in the form we have on our notes. Now that I have this written in the correct form, now I'm going to go back and I'm going to find my important characteristics. Since it's a parabola, the first thing I'm going to find is its vertex, and the vertex is at 1, negative 3. Since this is a parabola that specifically opens to the left, oops, I forgot my square there, the axis of symmetry is the line y equals k. Let's see, what should we find next? I guess that in order to find the focus and the directrix, we need to find p. So next, 4p is equal to negative 12, so p is equal to negative 3. The focus is at h plus p comma k. So in this case, it's at 1 plus negative 3 comma k. The directrix is going to be the line x equals h minus p, in which case it's 1 minus negative 3, which is 2. And that's your important information for parabolas. Problem B is an ellipse, and the reason I know it's an ellipse is because my square terms have different coefficients. So I'm going to have to complete the square. So I'm going to start with 4x squared minus 8x plus blank plus 9y squared minus 36y plus blank is equal to negative 4 plus blank plus blank. But in this case, in order to complete the square, your leading coefficient must be 1. So we start by factoring out a 4 from the first parentheses and a 9 from the second parentheses. And that's going to change the numbers that get plugged into the right-hand side. So, although the first term is 1, because you take half the middle term and square it, so this is x minus 1 squared. On the right-hand side, we plug a 4 in, because remember we factored out a 4? The only thing is we didn't know what the final term in the trinomial was. We really factored it out, but before we factored it out, it would have been a 4. The second trinomial, when you take the middle term divided by 2 and square it, you get 4. But the number that goes on the right-hand side is going to be 36, because you have to multiply back the 9 with that final term that really got factored out, even though we didn't know what that term was yet. And then when I simplify the right-hand side, the 4 and negative 4 cancel, you're left with 36. The last thing I have to do is divide everything by 36 because I want the ellipse to be equal to 1. So I get x minus 1 squared over 9 plus y minus 2 squared over 4 equals 1. Now I know everything I need to know about the ellipse. Now I have to find all the important information about the ellipse, like where's the center, The center of the ellipse is at 1, 2. Because the larger number in the denominator is under x, the major axis is going to be 2a, which is 2 times 3, which is 6. It's elongated horizontally. The minor axis is 2b. It's 2 times 2, which is 4. The vertices, you can either use the little definition or you can draw yourself a picture. I think drawing a picture helps me out quite a bit. Since I know that the center is at 1, 2, I can find the vertices. The vertices are 3 units to the right and 3 units to the left. So the vertices, 2 of them, are at 4, 2, and -2, 2. And then the other 2 are 2 units above and 2 units below the center. So the other 2 vertices are at 1, 4 and 1, 0. The foci always lie on the major axis. In this case, the major axis is the horizontal one. So the foci are at h plus or minus c, comma k. But I have to find out what c is. And remember, we have this thing, it looks almost like the Pythagorean theorem, but it's not really. So I can find c by doing 9 minus 4, which is 5. So c is the square root of 5. So the foci are at, what was the center? 1, 2, 1 plus or minus the square root of 5, comma 2. And I would leave the answer like that, but if you're really anal retentive about it and you have to write it like this, here's one of them, and here's the other. You can do that, but you don't have to. It's a waste of time. I'd just probably leave it like that. This next conic is a hyperbola. I know this because x squared and y squared are opposite signs. And I want you to notice it's x that's negative. That means that y is going to come first. Well, here's the thing. There is no other y other than that y squared. So I know that one of the terms here is going to be y minus 0 squared. Here's the next problem. Remember that subtracting something is the same as adding a negative. And I'm going to have to complete the square. So I'm going to start by doing this. Negative 4x squared plus 8x plus blank is equal to 20 plus blank. The reason there's only one additional blank on the right-hand side is because I'm only actually adding one number to the right. I don't have to, or to the left. I don't have to add 2 numbers. So first, I'm going to factor out the negative 4. Watch what happens when you factor out a negative 4. Notice that this does not become negative. The reason that that doesn't become negative is because the third term in the trinomial is always the square of something. Squares are always going to give you positives. What number goes in that blank? Well, this is a 1. But on the other side of the problem, we're not going to plug 1 into the blank. We're going to plug in negative 4. So now I have y minus 0 squared minus 4, x minus 1 squared is equal to 16. And in order to get it in the form that I want it to be in, I'm going to divide everything by 16. So I'm going to have y minus 0 squared over 16 minus x minus 1 squared over 4 is equal to 1. Now I know this is hyperbola that opens up and down. The center, which is what I always find first, is at 1, 0. The focus, or foci I should say, are going to be at h plus or minus c, k. And in this one, we find c by using this formula. So in this case, b squared, which is 4, is going to equal c squared minus 16. So c is the square root of 20 also known as 4 to the square root of 5. So the foci are at 1 plus or minus 4 to the square root of 5, comma 0. The vertices of the hyperbola are at h plus or minus a, comma k. So they're at 1 plus or minus 4, comma 0, which is, it's at 5, 0 and negative 3, 0. And the only other thing that we really want to know is the slopes of the asymptotes, not the equation of the asymptotes. I've already messed this up because the foci are not where I said they were. I was looking at the wrong set of definitions. Try that again. The foci are at h, comma k plus or minus c. So it's at 1, comma 0 plus or minus 4 to the square root of 5. And the vertices are at h, comma k plus or minus a. So it's really at 1, comma 0 plus or minus 4. So they are at 1, 4 and 1, negative 4. The slope is plus or minus a over b, so it's plus or minus 4 over 2, which is plus or minus 2. And that's all the important information about hyperbola. The last thing we're going to do is we're going to do some sketches of conics, and we're going to identify the domain and range. Remember, the domain are the inputs, the x values, and the range are the y values, the outputs. This is a circle. The center of the circle is at negative 3, 2. The radius of the circle is 3. So I'm going to 3 to the right, 3 up, 3 to the left, 3 down. The domain are all the x values between 0 and negative 6, and I should put this in the right order. And notice I put this in interval notation. If you want to put it in this notation, you can. How do I know that's the domain? Well, because the x values only go between 0 and negative 6. The range, the y values, go as high as 5, but as low as negative 1. And since they include those numbers, that's why we use the brackets in interval notation, or you can write it like this in the regular notation. For this last one, we're going to have to do a little bit of work to get to the final answer. First of all, it's hyperbola because the coefficients of the square terms are different. Since y is positive, I'm going to make y come first. So 9y squared minus 90y plus blank plus negative 4x squared minus 24x plus blank is going to equal negative 153 plus blank plus blank. Before I can complete the square, I need to make sure that the square term in each parentheses has a coefficient of 1, so I'm going to factor out 9 from the first parentheses. I'm going to factor out negative 4 from the second one, so be careful and watch your signs. Notice that I changed the middle term to a positive because I was dividing by negative 4. The first blank, the middle term divided by 2 squared is 25. The middle term divided by 2 squared is 9. But those aren't the numbers that go on the other side. On the other side, I have to put 9 times 25 and negative 4 times 9, which is negative 36. So now I've got 9 times y minus 5 squared minus 4 times x plus 3 squared is equal to 36. And then I'm going to divide everything by 36 to put it in the form I want it to be in, which is y minus 5 squared over 4 minus x plus 3 squared over 9 equals 1. The center is going to be at negative 3 comma 5. So I'm going to actually go and do a quick sketch rather than putting the graph up here. So I'm at -3, 5. There's where my center is. This hyperbola is going to open up and down, and it's going to open 2 units above and 2 units below. So it's going to look something like this. You can do your other points and make your box so that you have your nice diagonals for your asymptotes. But for the domain, notice that these graphs really go off to the left and right forever. So the domain is all real numbers. In interval notation, it's this. The range, however, is a little bit different. The range are all the y values greater than or equal to 1, 2, 3, 4, 5, 6, 7, or y is less than or equal to 3. The reason is because the graph doesn't exist between these two y values. So the range was written a little bit different. And that is the review for the Chapter 11 conics test.